Hello there, my name's Vince from My Mate Vince, and in this video today we're going to be looking at this Ubiquiti UniFi Switch 16, a network switch. This is a managed one. If I can get it to work, I'll be just using it as an unmanaged switch because I'm full up underneath my stairs now and I need another switch. This would be useful for myself to actually get working. Now, it was sent in by Ryan, and he basically said the power supply is clicking every few seconds, matching with the fans cutting out. And when he first of all sent this to me, I've had this for quite a few months now, it's just been sat there. It was doing that because when I plugged it in, I remember it would kick in, kick out, kick in, kick out. But now it's just completely dead. As far as I can see, there's no on and off switch anywhere. There's no lights. It's just completely dead. So let's take it apart and see if we can follow the power coming into it. Maybe it's going to be a power supply problem, or maybe there's a problem on the low voltage side, which is telling the power supply to stop working, and it might just keep rebooting itself. Not sure, but it should be an interesting one. Now, of course, I'm unplugged. I've still got to be careful though, because I've had it plugged in. There might be capacitors on the inside that are charged up. So let's take it apart. I think they're just mounting there. So I think I just need to undo this one, and these ones here. Well, I think I have to undo these as well. No, they shouldn't have made any difference. Why am I struggling to get into this? There we go. I was thinking you wouldn't have to undo the mounting ones. Right, we're in. So there's just a light that shines through there. So that must be like an indicator light. Okay, now we have our power supply here. So what we can do is we can plug it back in, and we can see, hold on, what's this? That goes through. That's a bit dodgy going through there. They should have done that over, not in there. You know what I mean? There. Right, okay. Let's see, let's put power into it and let's see what we have here. And if we've got, for example, 12 volts here, or 5 volts, or 24 volts, whatever this runs off, then that says to me that there's a problem on here. Mind you, something on here may have to enable it. Anyway, let's do it. I'm not going to put my hands anywhere near here. As I always say in my videos, do not copy. In fact, I'll leave that in there. Do not copy what you see in my videos, because lots of things will be done incorrectly. So I'm going to go to volts DC. First things first, just in case something's happened, let's just check the lead. So let's go to continuity. That's okay. That's okay. No short, and earth is okay with no shorts. Right, volts DC. So I'm going to keep my hands well clear, plugging it in here to begin with. Now I'm going to be plugging it in now. We're in. Right, so let's see what we have here. I can hear clicking. Oh, fan is going, look. I've just seen that fan there. You can't see. Hold on 1 second. Look at that. Every now and then the fans will go. There. There. Okay. So now, is that 12 volts stable? Is it coming and going? That's coming and going. Right, what we'll do is let's unplug it for a minute. And let's unplug this here. And let's see now, are we going to have stable voltage? Probably doesn't mean anything because there's no load on it now, is there? But let's see. All right, plugged in again. Here. And here. Wow, that's high. I can still hear clicking, so that's not normal. But that is high. But it's not stable, is it? Let's just go on the other ones. And that's all over the place. Let me get my scope on that. Let's see what it's doing. I think it's a power supply problem, which is actually a bad thing because power supplies are normally really hard to fix unless you understand electronics and understand them well, which I do not. So I'm going to plug in the network switch now. And let's see what we got here. Right, so we're all the way up here. Now, every time it clicks, can you see it's going up? Let me see if I can hold that. There, can you see there? Boom. So every single time it clicks, so it's dropping. Now that's interesting. This is what the multimeter doesn't show. Let's zoom in on the scope. You can actually see it dropping until it reaches a level and then pops back up again. Look. See? It goes all the way down to near enough there, then back up. So each one of these are 10 volts. So we've got 1, 2, 3. So right now it's 40 volts, then it drops to about 40 volts to 50 volts, isn't it? 10, why won't it focus? 10, 20, 30, 40. Yeah, so it drops to 40, boom, up to 50, boom. Now the clicking might not come out in the video, but I can hear the clicking. In fact, sometimes it goes, so it's jumping minimum of 10 volts, sometimes a little bit more. So there we go. So the power supply isn't doing what it needs to do. Right, brilliant. So let's unplug that. At least we know now we have to fault find the power supply. I think I'm correct in thinking that, because I'm thinking even without a load it should be relatively stable and it shouldn't be making that clicking noise, because the clicking noise is irritating. Don't you just love a bit of scope work? I know it rarely comes out on my channel, but that's because I don't really know how to use it. But I've been saying it for ages, but hopefully this Christmas I'm going to treat myself to an oscilloscope. Not a real high-end one, but one between maybe £200 and £300. And that way then, that would encourage me to understand if it's on my desk and if it's easily accessible, then hopefully I'll get to understand it more and use it more. I just need to find some videos out there that really explain it in layman terms, because the ones that I've watched have been already kind of like electronic engineers. They already know it. They need to explain it in a way that was explained to them maybe when they were back at college or university. So it's very easy to waffle on about something when you've already got 20 years background in it. But when you haven't got a clue about something, you need somebody to explain it to you in real basic terms. But hopefully if it's on my desk and easily accessible, then you'll see it more and more in the videos, and that way then if you don't know how to use a scope, maybe you'll start to pick up little tips and stuff through my videos, and maybe when it becomes useful to use. So yeah, I'm looking forward to that, because I haven't bought a sort of a new tool in a while, so that should be good. If you like oscilloscopes, there's a good chance you're into your electronics, and there's a good chance then you'll probably find the services of PCBWay very useful. PCBWay is your one-stop solution for all things PCB fabrication and assembly. From rapid prototyping to full-scale production, PCBWay delivers top quality products. So whether you're a seasoned engineer or a hobbyist just starting out, PCBWay's user-friendly interface makes ordering your own custom PCBs very easy. And PCBWay do a variety of different services, including but not limited to assembling your PCBs, CNC machining, 3D printing, sheet metal fabrication, and injection moulding. So when you're ready to take your designs to the next level, look no further than PCBWay and bring your ideas to life. So as always, a massive thanks to PCBWay for sponsoring the My Mate Vince channel. Now let's get back to this power supply and this network switch. Okay, we have a little green LED light here as well, and the power supply. So we've got a load of output capacitors. It's going to be the output capacitors. I bet you it's the output capacitors that it's not happy, because something like this is always on. So although it doesn't look very old, it might have actually been on. It's you know, the capacitors might have gone through a lot. So let's unplug here. Be very careful. I need to kind of check the voltage off the capacitors. Now, where is the massive capacitor? We have a transformer here. Where are the big capacitors? They look like they're in the middle here. These are stuck on. There we go. Well, let's see if I can measure the caps. Whoa, careful, Vince. It's huge. My word, it's absolutely massive. It's in the middle here. I think that's them, but I don't know. Well, there's no voltage there. Right, let's go to the output caps. So there's 3 output caps here. 1, 2, 3. No, 4. There's 4 output caps. Right, every single capacitor here is 63 volt, 470 microfarad, and I know I'm not going to have them. I haven't got anything here above 50 volt. 16 volt here, I need 63. Right, okay, so it's not just an option of swapping them out. Let's try to take them out of circuit and see, because I'm sure it's these things that are not providing the stable power. Let's quickly measure them for ESR in circuit, because that might pinpoint which is a faulty cap, and it saves me taking them all out if only one's failed. 0.09. So now, negative is this side here. Negatives are all on the right. So let's just zero the leads. So 0.09. Let's see what you got. Zero 0.02. 0.02. Oh, that's massive. But it is in circuit. Let's try this one. And that's massive. So these two are okay in circuit. No, that's out now as well. What? They're all out. What's going on? Did I somehow charge them up accidentally? Would it ESR me to do that? Let me try that again. It's all over the place. I wonder if my leads are iffy. Yeah, I don't think those capacitors are happy. And it would sort of make sense that it's an output capacitor problem. Let me take a picture of them so I know how to put them back in, and then I'm going to unsolder all 4 of them. So I use my desolder station, I unsolder all 4 caps, and let's measure them out of circuit for capacitance and also ESR, because the ESR readings were all over the place when they were in circuit. Right, now, 4 capacitors. Let's measure them again. Out of circuit, they're going to give us the true reading. So first of all, let's do a capacitance check on them. And they should be 470. Okay, 436, not too bad. 421. 420, this is worrying. 431, okay. Not a million miles away, are they? Let's go back to ESR again. And remind myself, it should be 0.09, worst case scenario. Right, well that one looks okay. It looks very good. Let's keep that one separate because that one is worse. Uh-oh, please be wrong. These are testing okay. I don't think it's the output capacitors. Uh-oh. Right, okay. I mean, could this be something on the main board which is causing this to jump? You know, where this is starting and dropping? No, because it's coming from here, isn't it, when we had nothing connected. I wonder what it's supposed to be outputting. Does it tell us anywhere? I wonder if we plugged it in, whether or not we could measure the capacitor and see whether we have stable voltage there or not. Should we do that? At least we then know that this side is stable. Yeah, I think we'll do that. Right, I've got to be really careful now. So, not put my hands anywhere near anything. Oh, hold on a minute, there's no capacitors. There's no capacitors, so what's it going to do? There's no capacitors. No, I better not, because maybe it will blow up these. Maybe it will blow up that sort of transistory, diode rectifier thing. Maybe instead of wasting my time on that, just for the moment, I wonder whether this would operate, because my bench power supply goes to 30 volts. I wonder would this be happy operating at 30 volts? And then, you know, if then I would know 100%. I mean, I'm sure it shouldn't be clicking like that. The power supply, you know. So what have we got here? This clicks in here, so we have the negative up the top, the negative this side, positive that side. Right, so this is 30 volts, roughly around 1 amp. Let's see what happens. Put that in there. Whoa, that wasn't nice. Hold on now. Oh no, maybe 30 volts is way too high. Saying that, we had 30 volts going into it, didn't we? 1 second, let's just make sure we haven't got some weird short. Now I'm worried. No, okay, right, let's start with the voltage much less. Let's go all the way down to 10, and then we can ramp it up. I'll tell you what, let's go to 5. I hope I haven't blown something there. It made a hell of a spark, didn't it? I am right in thinking that that's, yeah, positive up the top and negative down the bottom. So I haven't connected the right way? I'm sure I did. Well, that's there. Right, so it's not drawing anything at that level there. Where's my little light? My light should be doing something up here, shouldn't it? Or at least a fan, something should be doing something. Right, let's start upping the voltage. So I'm now at 7 volts. I'm now at 10 volts. Nothing's happening yet. 15 volts, there's still no amps being drawn. I don't know the way that sparks when it disconnects and connects. Oh, here we go. I just seen it just went up to 4, it just went up to 0.4 of an amp. There we go. Right, let's lower it back down. There we go, we've got a light on. Let's lower it down and see what it runs on. 13 volts. 12 volts. And now it's cut out. At 12 volts. Yeah, it's not happy. Right, so that's 18 volts now. Drawn 0.4 of an amp. Well look, it's never done that since I started the video, has it? So it has to be the power supply at fault. Which we sort of already knew, but we've proved it now. Right, so there's something wrong with the power supply. What is wrong with that power supply? See, if I had new capacitors, I would just pop them in, because I'm sure that when I look at that, I would say it's something to do with the output side of things. So I have a good look over the board and it all looks okay. There's no burnt components or anything like that. It just looks immaculate. I do find two smaller caps on the board. I just pop them out just to check them for ESR and capacitance. They're both okay. So then what I do is I put the big capacitors back in, the 4 original ones that I took out and also those 2 other ones that I just took out now. So basically all the capacitors are back in the board now. And I'm just going to check it with the FLIR cam just to see if there's any abnormal heat spots. You know, I know I'm not going to be able to fix this one. If I had another one, I could do diode test and go across every single component, but I don't know enough about switching power supplies. If it was completely dead, I'd give myself a fighting chance, but it's not completely dead. It's the fact that it's working, it's just not maintaining that power. I would have said it was capacitors, but I don't think it's worth me changing out those capacitors because when I took them out of circuit, they're testing okay. So I've got to be very careful now. Remember, this is live, but I've got a little plastic tool here. I just want to see where that heat's coming from. The chip. But it's only 30 something degrees. Right, now I'm going to unplug it and I'm going to turn it over. And we'll see if we can see any heat coming from the other side. And plug it back in. Don't worry about reflections. No, so the only thing getting hot on there is the chip. And maybe the chip is failing. Maybe it's starting, stopping, starting, stopping. T1755T. Well, that's nice and easy to remember. T1755T. I'm going to look that up. Right, this is the chip here. It's a high voltage startup DCM/QR flyback controller for integrated DCM/QR PFC controller. Power factor correction. Discontinuous conduction mode. Basically, I haven't got a clue what it does, but it controls. I think it's the main thing which is controlling the switch mode power supply. So I think I'm going to change it out because they are available. They're off the shelf. They don't look like they're programmed or anything like that, which is good. And I think I'm just doing it for an end to the video. If it fixes it, fantastic, but I don't think it will. It could be something to do with the feedback, because if you have a look here, we know that it's going from 50 volts down to 40, then back up to 50 again. But look, you know, there's loads of sense pins here and there's feedback and stuff like that. You see these feedback ones here? So if it was completely dead, then I'd have more chance of fixing it. But for me, this would be impossible for me to fix because I don't even know how I would go about fault finding it. I'm only swapping this out because it's doing the main thing. It's the most important component on the board, which is working the hardest. So that's the only reason I'm doing it. Yes, it had a little bit of heat to it, but I presume that's completely normal. If I change it out, it still might not work because maybe it's not happy with one of the sense ones coming back or the feedback ones coming back, and that could be down to, for example, one of the little resistors or something like that. But there's a lot of components on here. I don't really want to go across every single one in the hope that one might be faulty, because for example, when I measured the other resistors in circuit here, they weren't reading anything like they should do. So I don't want to unsolder everything from the board to test it. So I'm going to get one of them, pop it in, and if it doesn't work, unfortunately I'm going to hand that over to the comment section and then see if anybody's got any bright ideas, because I'm sure somebody out there will probably have a good idea what it might be. So it's got a lot of age to it now, 2012. So it's, you know, it might have been in operation for 10 or 11 years quite easily. Yeah, let me get a chip, pop it in, and you never know, it might just start working.
11 days later.
Right, it's only been about a week-ish, I think, and 5 chips have arrived from AliExpress. Let's zoom in and see if we have the same number chip. And then let's pop it in. I have no idea if this is actually going to make a difference. Right, T1755T. T1755T. Brilliant. Okay, right, let's get some flux on that. And let's take the old one off and pop the new one on. So while I'm swapping out this little switch mode power supply chip, I'll give a shout out to the My Mate Vince Massive, and the members are kitdigital.com, Kip Hakes and Max Rokotansky, Chris Seal, Felipe at MrKeebs.com and DJ VG, Pigsy, Anthony Dean and Bazza2, Russ Melanson, Gaspar Heller, Rickard Berglands, Soul Reaver 555, Shamsa Al Sawadi, Stuart Park, and Stephen from the Broken Past over on YouTube. So massive thanks to each and every one of you and all the other members that support over on Patreon. It's a stubborn one. Do you know what? These are stuck down. Can you see there's bits of glue? This is wave soldered. These are stuck. So right now that is loose. I'm going to have to force it up. It's the glue. It's the glue underneath. There we go. Can you see the glue? So I could have been heating that up all day long and the glue might not necessarily have actually melted. See that glue there? Right, so there's a pad lifted there. I've got to be really careful. Uh-oh, don't want to break that. So basically what happens is, when it's getting manufactured, all these things are stuck down. So a little bit of glue is used on everything. They're stuck down and it looks amazing. Google it if you haven't already seen it. What then happens is, this will be upside down with all the components stuck on it. And a wave, an actual wave of solder comes along and goes across the whole board and it solders everything. It looks amazing. I mean, the idea of that to begin with is just brilliant, to think that somebody actually thought of that. So that's why it was so hard to take off. It wasn't that the board was thickest because it was glued. I should have noticed. Can you see there's little bits of red everywhere? In fact, there's an obvious bit there. I've got to be careful around this one here now. That'd be fine. I'll force that down with the chip. Now I know you're thinking, because I've just looked through here, you're thinking that that's a break there and that's copper. That's not. That's a little bit of red glue. There is no break there. That's red glue. So that trace is intact. Right, let's get the replacement one on. So that little pin is going down there. Hope this fixes it. I'm just going to force it down with my hand, and to begin with I'm just going to get a corner tagged. I've got to be really careful because of that broken one. Gone off. So there, and let's do a little bit here. There. Now I'm just going to move that little pad over again, then we'll use flux and we'll do each of them. There we go. Well, I'm happy with that. Let's give it a clean up. As always, I'm using isopropyl alcohol to do the cleaning. Right, and it looks like that dodgy trace goes to this capacitor here. I just want to check if it goes here as well. No, so here, so it was this one. There we go, so we're fine. Right, there's nothing short in there, and everything looks fine. Plenty of solder on each of the legs. So let's put it back together and see if it's doing that pulsing thing. Okay, we're plugged in there, plugged in here. Let's plug this into here. Nothing's going to short there, is it? No. Underneath. Right, I am safe. I am safe to plug in. Yes, keep my hands well away. That's all good. Here we go. Please, please, please work. Oh, you git. Oh no, it's still ticking and the fans are still doing that thing. Oh, what? I don't think I can fault find that anymore. I don't know what else to do. I don't think it's the output capacitors.
Ha ha.
Could it be the main massive cap? Let's unplug it. Oh, what? I thought it was going to be the chip controlling it. Hashtag gutted. Well, I might as well keep that old chip then because there's nothing wrong with it. Okay, what I'm going to do is... Do you know what? I didn't want to have to get involved with undoing. See, there's going to be like switching transistors and stuff in here. It could be them. I'm going to have to unsolder this shield. So we've got a point here, a point here, a point here and here, and undo the screws. I presume the switching transistor under there. I mean, it could be, well, I mean, it could be anything. Opto-isolators, could it be that where the feedback's wrong? I don't know if I'm going to spend any more time on it because I'm not sure whether I'm going to be, you know, I don't know where to take it. Let's unsolder that. Take it a little bit further. Maybe what we could do before we unsolder that is there's a massive cap here. You can see the size of it. Yeah, just in here. So I presume these two big ones here are going to be for the cap. Should I go on to DC voltage and see if we have our, whatever it is, 300 and something volts? Because maybe it's a problem on the primary side, you know, not the secondary side or something. Obviously I'm keeping my hands well away. Now for those that like to play along at home, because I know there's a few of you, this next bit now, watch very, very carefully because you might be able to work something out from this next bit. I ended up learning something that will stay with me forever. And some of you will already know it, but some of you won't, like me. So I promise you by the end of this video you will have learned at least one thing. Probably nothing else, but at least one thing. Right, I'm plugged in. I can hear it clicking. Let's see how stable that is. Right, that's stable, isn't it? So I think we can assume we're okay to there. 328 volts. Let's see how quickly, I've just unplugged it, how quick that drains. Yeah, it's like instant. So it looks like it's okay up until there. Let's unsolder. Maybe I'll find a burnt component. Now isn't it interesting that that massive capacitor, and it is huge, drained away that quickly? On the Panasonic system that I did recently, from memory, that drained away as well. So sometimes there can be these massive bleed resistors across them so that it gets rid of all that voltage after you turn them off. And there might well be resistors hidden in here somewhere on the other side, but it did drain away very quickly. As soon as I unplugged it, I got those probes back on and it drained away. Anyway, what follows now is probably around 2, maybe even 3 hours off pulling things off the board and testing things in my little meter, because I don't know what's wrong here. I haven't got another one to compare to. Power supplies are incredibly hard to work on. When you watch videos on them, you think, yeah, I can get my head around that. But what you don't realise until you start trying to work on them is that every power supply is different. Yes, they might have the same core principles and the same core components, but they really do vary massively from one power supply to another one. Some of them will just have the one chip, some will have 2 or more chips. They seem to just have, it's very hard to pinpoint. The only components I can pinpoint really is the bridge rectifier and the incoming fuse, and after that I kind of get lost. When it goes to beyond the main filter capacitor onwards, you're just dealing with a whole different array of things on every power supply you work on. Even though they all work in the same kind of way, they're very hard to fault find because they just seem to have various different diodes everywhere, and resistors and chips and secondary capacitors. They're incredibly hard to work on. And to be fair to myself, not many people do actually work on power supplies because normally time means money, and power supplies are known to be hard to work on, and it's probably just as easy just to buy a replacement power supply, or maybe even modify this, just have an external power pack and then just have a barrel jack on the back. It will still work the same, and it would probably be cheaper for a repair shop to do that than fault find a power supply. But the thing is, I do believe that if you did enough of them, because already when I think back to that PlayStation 4 that I did all those years ago where I had my first shock from a capacitor, I'm not saying I know much more than then, but I have fixed a few power supplies since then. Off the top of my head, I'm just thinking of the Panasonic one that I did recently. I'm thinking of the Ministry of Sound one that I did. I'm sure there's been others as well. I just can't think of them. So I think the more you work on them, you will get better at them. But also, the more I work on them, I realise how little I know about them because they're just so complicated compared to, let's say, a linear power supply, which is just so much simpler because you just have a massive transformer and then it just rectifies to DC after that. You can kind of get your head around that, but switch mode power supplies are, for me, the equivalent of rocket science. But anyway, let me show you a little bit. One of the things I do like testing is the opto couplers. So I pull those out and I'm just going to show you testing them, and then we'll move on with the video. Now, before I take out the big transistors, I've decided to take out the opto couplers because to me it does seem to be a feedback thing. It seems to be working and then not liking the feedback and shutting down. Working, not liking the feedback and shutting down. But why do I think that? Just out of desperation because I'm going through everything bit by bit. Right, let's solder up. So basically these are the little opto couplers here. And these are called 817C. 817C, and this is the pin out of them. So I'm going to put a 1k resistor onto the anode, which is this one here. Then I'm going to apply voltage. I'll only do maybe like 2 volts to start with, and then I'm going to use my multimeter in resistance across these two, and I want to see if it reads something. Then if it reads something, I'm going to go to 2.2 volts, 2.4 volts, 2.8 volts, 3 volts. The resistance should change as the LED, because we're basically lighting up the LED. And I'm using the 1k resistor to protect the LED from burning out. So let's do that and see. That will tell us if the opto couplers, well, it will roughly tell us if they're doing something. But it doesn't mean to say they're not going to be faulty. Maybe they're not working as well as they should do. But what would be nice is if one works, one doesn't, then we know that is the problem. So bench power supply set to, let's do 2.2 volts. So this is going to be the positive here. Now I've got to try to get this onto here without shorting. Let's bend it out a little bit. leads are not the best. Right, it should be lit up now. So if we use our multimeter, let's see if we're getting something. So I'm in resistance. Yeah, we're getting something. 2,500 ohms. Now let's up it to 2.6. Let's see if it's changed. Yeah, there you go. So now we're down to 700 ohms. So this opto coupler is working. I'm just going to go to 2.9 volts. And now we're gone to 600 ohms here. So as far as I can see, that one is working. Let's do the same with this one here. So I test the other optocoupler in the same way I tested this one, and it's testing okay. I don't really know if it is testing okay, but it's given me a reading. Interestingly, they are different, meaning that if I was to put 2.5 volts into one, it might be 700 ohms. Put it into the other one, it might be 400 ohms. I'm just using that as an example. So basically, they're not the same, even though they are the same optocoupler. Maybe that's why I've got a problem. There might be some imbalance in the feedback, but I don't know. I mean, why is there even two optocouplers in this circuit? I might be dreaming, but I'm sure I've seen power supplies with just a one optocoupler. So if one will work, why do you need two? And this was what I was mentioning earlier about all power supplies seem to be different from each other. Now that I've mentioned that, I'm already doubting myself, and maybe they all have two optocouplers. I really don't know. But yeah, anyway. I take a few other components out, put them in my component tester, and they appear to be testing okay. So I've kind of taken it as far as I can take it. This for me is a failure video. I cannot fix it. So my options are to buy another one, but when I look on eBay, I didn't realise they were so expensive. A working one is over £200-ish. That's a lot of money. Too much to spend to buy in order to try to fault find this one. In this instance, I'm happy to pay 20, 30, 40 pound, but I don't want to pay 200 pound on something, because the video itself might not get that much views, and it should make 200 pound, but it might not make much more, in which case then you don't want to spend 200 pound on something, because then I might find it hard to sell, and then I'm kind of stuck with two of these things, even if I get this one working, when I only actually need one. So yeah, for me, I can't fix this one. So I turn to Google. Now, people will argue that I should have turned to Google hours and hours ago before I even attempted this. I would argue that no, I wouldn't want to do that, and I don't want to go down that road, because you see, if I start to know what the problem is before even going into it, for me, it becomes boring. I'm just a pair of hands using somebody else's knowledge. While if I try to fix it myself, at least then I've tried, and I might have learned something along the way. If then it's a failure like this, of course I'm going to turn to Google or whatever means necessary to try to get a successful outcome to the video. But the outcome to this video right now is that I cannot fix this. It's too hard for me. I've tried my best. I've taken it as far as I can take it. But when I look at Google, interestingly, there's a forum, and interestingly, loads of people have the same problem with this power supply cutting out, or the fans cutting in and out and making a clicking noise, just like this one here. So that's the great thing about the internet. Often, if you've got a problem, you will hopefully find other people with the same problem, and a few people have done stuff that has ended up making this work. So I'm going to cut to the video now where I've done my research on Google, and now I've got more knowledge. I'm going to show you this forum that I found. Okay, I've been unsoldering various different things. You can see the amount of mess I've got here. I even unsoldered this transformer here to see if I could find any breaks in the wires, which I couldn't. I traced the voltage input of this chip to the little capacitor that we have already tested previously, but I had one of those, so I did replace it. I'm still getting the ticking upon startup. And I googled it. I should have googled it from the beginning. There is this 11-page forum about this particular one. Well, actually, I don't know if it's about this one, but it's about a Ubiquiti switch. And people are saying that their power supplies failed on it. And loads of people saying they're getting a clicking from it, which is exactly what I'm getting. Now, the majority of people have just replaced the power supply, because obviously most sane people wouldn't get involved in trying to fix this. but there must be about 4 or 5 posts in here that said they replaced this one here, and it started to work, and they said they could see their one was visibly bulged. Now, I wouldn't call mine bulged, but you know what? It is a tiny, tiny, tiny little bit higher right in the middle. The problem is that people can't get the right size replacement, because if you look at this one, that's not the normal shape of a cap. So therein lies the problem. But for me, I just want this to work, and maybe we can run the cap and run it outside. Or I seen another thing on the post where somebody had cut the actual shield and then just pop the cap up through there. So that might be an option, because we're going to have enough clearance when it comes to in here. So yeah, I mean, that doesn't look bulged to me, but a few people said it fixed their one. So I would have thought it was fine because I had stable voltage here, but maybe it's putting a fault condition on which it's not happy with. So let's unsolder it and see if that brings us any, let's see, maybe I can test it. Maybe the capacitance is well out. So I would have never suspected that this was at fault. That was a good one. Look at that. Okay, so here it is. Well, looks good down there. So this is 450 volt, 150 microfarad. Let's first of all see what the reading is. Maybe this is high ESR or something. I'm not sure if my ESR will test this one here. My meter, I don't know if it will go up that high, but let's see. So we're looking at 150 microfarad. 180. Hold on. Oh, 1 second. I'm getting confused now. That is the same. So that's come. Is that not the 150? Let me just double check. That is the same as 162, isn't it? No, hold on. I got that wrong completely. A nanofarad is much smaller than a microfarad. Hold on. What's going on here? 1.1 nanofarad. Well, that's tiny, because so 0.1 microfarad would be 100 nanofarad. What? So this isn't actually. I'm worried that my meter isn't reading that correctly. That seems very, very, very odd. And according to that, that's like failed completely. Let's plug it into my ESR thing. Right, well this one doesn't go up to 450, but let's get a reading at 250 volts, and we'll go to 100 microfarad. So that should be 0.8 worst case scenario. So I presume if it was 450, it's going to be maybe 1 point something. Not even being recognised. Well, it looks like then. I mean, that's the first thing I've got, which isn't, which is actually showing as faulty. Yeah, look, that is a little bit bulged. So, for example. Can you see? It doesn't want to, it is about 1 millimeter away. Let's put it on something flat so you can see it. Yeah? Can you see the difference there? Well, if I was to take this one here, well, this has glue on it, but can you see there? That does lie flat. This one doesn't. Okay. So I wonder, has it dried out or what? Why has this failed? I suppose it's on all the time. Meaning this thing's powered 24/7, isn't it? Well, I think this is going to fix it. I'm just really disappointed because I didn't find the fault. It was a forum. So, I haven't learned anything because I would have never thought, well, I suppose I've learned to maybe check these, but as far as I was concerned, the voltage was stable here, so I thought it was okay. Right, now, how dry are you? Nice smell. Well, there you go. That's the cap, you see, with all the windings, and it's all going to be insulated from each other. So we have the outer, and does this go towards the middle? You know what? That's crumbling there. I think it's actually... Hold on. Where does that actually go? That's there. I wonder, would we have resistance now? I think maybe. It ate through. Not resistance, capacitance. Look at that. 58 microfarad. It ate through. Can you see this bit? This bit here? See, it was kind of black. I think it ate through it. Because we're getting a reading now. Yeah, there you go. So that's 237 that way around. I don't know which is positive and negative. And if I go this way, it's 120 microfarad, and it should have been 150, wasn't it? I bet you now, which I can't because it's messing with high voltage, but if I was to solder that onto there, I bet you it would now work. Do it, Vince, do it. Everybody wants to see you do it. So yes, I'm going to try to fix the capacitor. Of course, in real life, you would not do this, but it will be entertaining for the video. As we add the high voltage back into it, will it go up in a puff of smoke? Will there be a little bit of a bang? Will there be a few flames? It'd be interesting to see. So I tried to solder on the strip, but it's not having it. I don't know why. The solder just doesn't want to stick to it. So I have to get my spot welder out. I know this is complete overkill and ridiculous trying to fix a capacitor, but still, you got to admit, it is a bit of fun. So I weld on a little nickel strip to make it a little bit longer because the old one's been eaten away. And then I weld the other end of the new nickel strip onto the bit that's left, the tiny little bit that's left on the actual capacitor. I have to do a bit of folding because it's not really welding or sticking very well. I don't know what this strip is. I'm saying it's a nickel strip, but I don't know. Solder doesn't want to stick to it, and even the spot weld's struggling a bit. And also, what caused the failure here? Is it a worn out cap? See, I don't think so. I think this is some sort of manufacturing defect from this cap, that maybe from the very beginning it was getting eaten away, and then after so many years of use it's eaten away completely. It doesn't look like a dried out cap or a cap that has kind of bulged. It looks purely that somehow the electrolyte has kind of eaten through the little nickel type strip. But yeah, very odd. Put it down in the comment section what you think. Maybe this is just a sign off a worn out cap from age and use. But to me, it seems more like the fact that one nickel strip's gone and the other one hasn't. That maybe this particular nickel strip had some sort of impurity in it that the electrolyte attacked and then ate through, kind of went like a kind of a powdery and just ate through. Not too sure, but if it's happened to this one, maybe it was a bad batch of caps, and maybe there's quite a few of these machines out there that is suffering the same fate, because maybe the caps that were put in from new are a bit iffy. Not too sure. Again, add it down to the comment section. It'd be interesting to hear your thoughts. Obviously, I have no idea, but it's interesting to see that on the inside, one nickel strip seems to be fine, and the other one seems to be eaten away completely. So anyway, let me get this cap put back together, and we'll do a little reading on it, and then we'll put it in circuit, and we'll see what happens. There we go. You would probably find it quite hard to tell that anybody was in that there. And clearly it's going to be 100% safe. Now let's check what it is reading. So before it was in the nanofarads. Now, come on. Look at that. 138 microfarad result. Right, let's solder it in. I'm going to turn it on from across the room. Now, so I did put that on there just to let me know which is the negative. So it's this one here, and then on the board it clearly shows me that the negative is this hole here. So let's put it in and see what it's going to do. There we go. Let's measure one more time. I know it's in circuit now. 142 microfarad. Whoopee! Okay, so I've got it roughly together. I'm going to turn it on from across the room again. Let's get that out of the way. Look at that mess of everything. So much work's gone on here. Right, I've got that connected to the input there, but everything's connected up. Let's see now if you're going to see the fans spin. Well, you can't even see that fan there, can you? It's a heatsink, but you should be able to see that one there. Right, I'm plugging it in now, and then I'm going to go across the room and plug it in. Let's see if anything goes bang. Ready? I'm confident now. I'm confident. It's going to do something different. I think it's going to work at least for a few seconds. Here we go, on now. Come on. I can hear fan spin. I've got 53 volts. I have 53 volts. And I've got a light. Can you see the light? The light here? Look, 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 the light. And the fans are spinning. I'm wary about that capacitor. Check it out. Hallelujah. We got there. I'm turning it off. I'm plugging it now. Oh, result. So all along it was the capacitor. Now I can buy capacitors very cheaply, but they're all the wrong size. But not that cheap. They're still going to be about £4 or £5 delivered. But if I have a look at this one, I'm paying more. It's £10. Or best offer. I might try to put the cheeky offer in. I might go in at £8, you never know. But anyway, look. It's showing here that it's 35mm wide and 25mm high, which looks to be the same as this one here, and it says the pitch is 10mm, which is the same. So I think this one is actually going to fit. So I'm going to put an offer in for this one.
A few days later.
It's arrived. It was up for 10. I offered 8. They countered back with 9. I didn't really have much choice. No one else is selling them, so I would have paid more than that. Here it is. So yeah, as you can see, a nice stubby capacitor. £9, a lot of money to pay for a capacitor, but it is what it is. Now, let's see. It's well worth fixing this item, you see. So even if this was £30, it would still be worth fixing it. Well, mind you, you might as well try to get another power supply. What am I doing? Let's just see what capacitance should be. 150 microfarad. There we go, 143 results. Okay, let's pop this in and let's see if we can get some network activity through this switch. So I have to unsolder my beautiful creation of the fixed capacitor, and I have to put in the proper safe capacitor. Annoyingly, the capacitor is a few millimeters too tall, and the massive heatsink shield thing doesn't go on properly. So I have to do what I've seen in the forum, which is cut a slit in the heatsink, and then I have to kind of bend it up around the capacitor. It looks awful, but it's still providing a heatsink to the components that need it, these kind of switching transistors, and also the bridge rectifier is on there as well. Of course, I applied the incorrect amount of thermal paste. That is always a given. And yeah, I have to put it back together. It's very fiddly because the holes don't line up perfectly through these switching transistors now, because of course the heat shield is just a millimeter or two too tall, because it's kind of fouling against the capacitor a bit. It's all become a little bit of a nightmare, if I'm honest with you, just purely because there's a bit of a specialized capacitor that you can't easily get. So anyway, I managed to get it all back in. It takes a while, and now we're going to start filming again in real time as I'm about to turn it on, and at long last we should see the switch come to life. Right, here goes. Let's plug it in. Let's see if it comes alive. Oh, I don't believe it. Oh, I don't believe it. What? Don't do this to me. What have I done? Oh, I've just tripped all the electrics. Oh, I'm absolutely gutted. So what's happened in putting that cover on or something? I bet I've broken one of those switching transistors or something. Unless, of course, there's something iffy with the capacitor. I don't know what it is at the moment, but just honestly, every single fix just seems to go against me. I've already spent ages on this. Honest truth is, I don't want to spend any longer on it. Well, I'm gonna take a break. Oh, I feel so disheartened. Oh, Vince, stop your moaning. It's not that big a deal. It's the switch that blew the electrics. In the grand scheme of things, it doesn't really matter. It's just I've had a bit of a run of items that are very hard for me anyway to fix, and I wanted this one to be easy so I could just get a video out there. I've been struggling recently with the output of my videos because just every job just seems to be going against me. But anyway, it's just the way it is. It's no big deal. So apologies if you're going through a load of rubbish and you're watching my videos to try to escape, and then you just hear me whinging and moaning about something which isn't a big deal. So yeah, apologies for that. Now, going forward, there is actually another video's worth of fault finding to do, but I'm looking at the length of this video so far, and currently I'm on 1 hour and 5-ish minutes. Hopefully I'll be able to edit that down a little bit more. So I'm just going to tell you what this next problem was, because it was man-made. It was me that did it. It wasn't a natural fault. It was something I did. So basically, the power supply now isn't outputting anything, and the reason it's not outputting anything is because the fuse is blown. But there's something that's caused the fuse to blow. And when I put the heat sink back on, because it's a little bit higher than it was before, because the capacitor is higher, and when I bent up the metal, clearly I didn't bend it up quite enough, it means it's sitting a bit higher. That then means that the holes that are drilled for the bridge rectifier and also the MOSFET and the diode or whatever it is, they're a little bit misaligned. And I remember when I was screwing them in, it was incredibly hard to do because the nut is hidden underneath the heat sink, and then you're trying to screw it from one side while trying to hold the nut with like pliers through the grills of the heat sink. It's not very easy. And I must have put a little bit too much force in trying to line up the holes, and I remember hearing just a tiny little click. That click was basically fracturing the MOSFET. So now the MOSFET is shorted, and because it's shorted, it's basically I don't know, it must be putting the live down to ground or the live against a neutral or something, and it blew the fuse, and also the MOSFET's gone as well. So the reason I spotted this is because the bridge rectifier wasn't testing properly. When you do diode tests on the bridge rectifier, you will normally have a read-in. If you put one probe on and go across the other legs, you will normally have a read-in one way, but then when you swap your probes, you won't. Well, on one of the legs, I had a read-in both ways. So basically there was like a short on it. So that's the reason I found it. But it did take me about a good maybe hour and a half to actually fault find it. I had to take loads of components out to just follow the traces alone. But yeah, it was man-made. It was by me with the misaligned heatsink. I put too much strain on the transistor, the MOSFET, and I cracked it. So what I'm going to do in this next part of the video now is I've put a fuse in. I haven't got the correct part, so I'm putting in a MOSFET, which is also high voltage. It's also an NPN, but it's not the MOSFET that came out. And I've also put in a 4 amp fuse rather than a 3.15 amp fuse. But this is purely for testing. So let's cut back to the video now. When I've done my fault finding, I've got the replacement wrong fuse in and I've got the replacement wrong MOSFET in, purely to see if it works. Right, okay, I'm ready to plug in. So replacement fuse, same bridge rectifier, which I'm nervous about. I'll just measure that now. Obviously, I can't use that N-channel MOSFET. This is purely for testing. Basically, I just want to finish up the video now. I can always buy one of these in my own time because you can see this isn't insulated. So this is going to be put in the drain down to ground if I was to leave this in, because when I put the cover on, that's going to be in contact with that. So I could put a little insulation piece on it, but I might as well buy the correct one if I can get it working. But yeah, I'm not sure. Let's just go across this bridge rectifier because I'm not sure whether, let's see what it's reading now. Nothing, nothing, nothing. Something, something. Oh, what? Wow. That's reading what I would expect it to read. What? So in circuit, that's interesting. Okay, I think the bridge rectifier is okay. Right, I'm actually a little bit hopeful. Let's let's plug it in. Oh, it'd be great if it could work. Well, I'm going to plug it in now and then go across the room again. So we are connected there, we're connected there. Will it go bang again or will the fans spin? Let me put this here so you've got a visual indication of what's happening. Wouldn't it be great if we seen whatever voltage it was, the 50 volts. Here goes. Wish me luck. Last chance now. I'm turning it on and I'm going to reset now. I've hit reset. Oh my word. What's that? I can hear a fan. I've got 53 volts. The fans are spinning. Oh, hallelujah. The fans are spinning. No way. I've got to be careful because of that N-channel MOSFET. So I need to buy a new fuse and a new MOSFET. So clearly I snapped the MOSFET when I was trying to get it into place. Oh, hallelujah. I'm going to order some of them up. Can't tell you how relieved I am. Result, I've unplugged it. Oh, brilliant. Let's just make sure it's not a fluke. I'm going to plug it back in again now. And there we go. Oh, I can see the light at the front as well. I think to finish up the video, I'm not wasting any more time on this video. I want to get it released because I've got no content. Honestly, since Christmas, I've been struggling to even get out one video a week, yet I'm working full time. I've just been having nightmare fix after nightmare fix after nightmare fix. Let me just connect up something to this and maybe connect a laptop into it just to show it working as a switch. And then definitely I've proved the end of the video. I can't put it back together because I need a new MOSFET there. I'm so happy with that. I can't tell you. And just to show you that I am going to get them, you can see here I'm getting these ones here. It's a lot cheaper to get them from China, but this one's a UK seller in Devon. So I'm just going to buy this one and this one here. I'm getting 5 of these with the leads on them. I'll put my own heat shrink on, and then this one here. There we go. Order confirmed, £9.35. Oh, what a relief. Right, I've got it connected up and lights are flashing and stuff. I've got to be careful because the cover's off. But yeah, it's not connecting. If you have a look at my switch there, it's still on Wi-Fi. It hasn't automatically gone through to Ethernet. Yet if I look at the ports here, you can see that it is lit up. Right, there is apparently a reset button here. So I'm going to hit the reset button and I'm just going to hold it for 5 seconds or so. You normally use a paperclip for this. I want to see if that will reset it because I think this is connected to Ryan's system and that's why it's not allowing maybe it to work as an unmanaged switch. So I'm going to let go now and we'll see now after a few minutes if that comes back alive. So what we got here, white. It goes to blue and everything. I want to be a bit wary because I don't want it plugged in too long with the wrong components in there. There's nothing happening at the moment. I wonder, do I have to unplug it now or not? Oh, it's flashing white. Oh, now we've gone to blue. Now we've gone to there. Oh, it's doing something. Are you going to work? Are you going to work? Still doesn't want to connect up to it. There we go. Results. Yes, it's connected. Brilliant. Right, let me go to the computer. Just get rid of everything. Right, there we go. Ethernet connected. So let me just disable Wi-Fi. Right, so I'm going to disconnect from the Wi-Fi. There we go. So now we're just connected to there, and let's see if the internet's going to work. Ah, happy days. YouTube. And this is working on the Ethernet. So if I go down to here, you can see there, that little symbol there. Ah, hallelujah. Right, so it just needed resetting, which was good. So now I made a right meal out of that. If I just used my brain and thought about it, why was it not holding charge? If when I plugged it in and it measured, for example, 320 volts DC or 330, whatever it was, if then when I unplugged it, it went straight off. I know now from now on to check the capacitor for capacitance. Even in circuit, I could have checked it for capacitance. Obviously, a lot of power supplies will have like bleed resistors and stuff across them, but still there should be a bit of charge there for a while. Well, with this one, as soon as it was unplugged, there was no charge. So it's so simple now, I know, but I never thought to check that before. So I have actually learned something in this video. If I had known it was that cap, then I would have saved myself so much time. I was just fault finding my way around this whole circuit, undoing everything. And when you do that, it leads to problems. You damage wires. In my instance, I damaged a little MOSFET, which caused me even more pain. But the bottom line is we got there eventually. If I got one of these again, I'd go straight for the filter cap because it's going to be a common problem on these. And anytime I'm working on power supplies in the future now, I'm always going to, I've never had a faulty cap. You know, that big one, I've never had that go before. But now I know to check that, and it's a nice easy thing to check. So I've definitely learnt something in the video, which is the main thing. I found it quite painful just because, you know, when it cut the power that time, I'd kind of had enough of filming this one. But bottom line is we got there eventually. When I get the new components, I'll pop them in, and I will actually use this. This will be going under my stairs, and that way then I have a nice 16 ports to work on, and it means I have power over Ethernet if I need to in the future. But at long last, we have something, which is fantastic. So a massive thanks to Ryan for sending this out to me. I appreciate it is an expensive piece of kit, so thanks for sending it to me. That's very generous. And yeah, I will get use out of this once I change over those components. So if you enjoyed the video, give it a massive thumbs up, and I will see you all very soon. Thanks for watching.
Leaving all my worries, I prepare for something new. Whatever it was that held me back, I'm sure it wasn't true. Holding on too long and unresolved questions hold you down. What could have been a friendly smile has turned into a frown. I'm moving on and on. On and on. I'm moving on and on and on. I'm driving in my car, the road is long and full of dust. The landscape changes around me, on and on, I feel immersed. Whatever happened to me happened for my